In this video, we will review some concepts relating to similarity. For starters, if two polygons are similar, then their angle measures are equal and their side lengths are proportional. So you should have chosen option D. Now just remember, when we're talking about similar figures, they're going to be the same shape, but they will be different sizes. So if you said the angle measures are equal and the side lengths are equal, that's why that would be wrong, because you can have a small figure and a larger figure, so obviously the lengths will not be equal. So when we talk about the scale factors and we do new over old equals new over old, we're saying that the side lengths are proportional. That's the vocabulary word for what we're doing there. Alright, problem number 2. Triangle RST is dilated from the origin by a scale factor of 4/3. What will be the coordinates of point R prime? Well, what are the coordinates of point R in the first place? Let's start with that. Okay, so R is 3, 6. So if we're going to find R prime, we're just going to multiply both coordinates by the scale factor. So we're going to do 4/3 times 3, and then we're going to do 4/3 times 6. So that means that R prime, now 3 is like 3/1, 6 is like 6/1, so this would be 12/3 and 24/3. I'm just multiplying straight across. So of course 12/3 is 4 and 24/3 is 8. So 4, 8. So the answer was D. Alright, triangle ABC has been dilated from the origin to create triangle A prime, B prime, C prime. Find the scale factor. Well, you can just pick any pair of corresponding points. So just for simplicity's sake, I'm going to use B and B prime. So notice that the coordinates of point B are 4, 0, and then the coordinates of B prime are 6, 0. So when we do the scale factor, we always do new divided by old. Alright, I'm using K to represent the scale factor. It's always new divided by old. And of course the prime, the B prime, will always be the new shape, and the B is going to be the old. So if I do new over old, in this case, just look at those x values. That's going to be 6/4, which reduces down to 3/2. So the scale factor is 3/2, and you should have chosen B. Number 4 is a little tricky. It says, which of the following pictures shows a triangle and its midsegment? So you know that the midsegment should be half the length of the parallel side, and there should be a parallel side. Also, you know that a midsegment connects midpoints. So I'm really looking for all of these things. I'm looking for midpoints, I'm looking for parallel sides, and I'm looking for the midsegment to be half the length. If any of those things is not true, then I know that it's not a midsegment. So for example, we know that this point is a midpoint because the segments on either side are 6 and 6. Similarly, this is a midpoint because it has 5 and 5. So this is connecting midpoints, so you know this is a mid-segment. So I'm going to circle that one. Now looking at these, I don't know anything about midpoints, but I have parallel sides, and I see that the segment on the inside is half the length of the parallel side. That will only happen if this is a mid-segment. So this is also a mid-segment. Now this one, I automatically know that this is definitely not a mid-segment because the parallel line is not half the length. So this is 20. So if this smaller line were a mid-segment, it would be 10. But because it's 9, I know this is not a mid-segment. Now, this last one is the one that's the trickiest because they do give you the 8 and the 8. So that lets you know that this is definitely a midpoint. So it's looking good so far. But they don't give you any lengths over here. So you might have been thinking, well, we don't know that these are the same. These could be anything. You know, this could be 9 and this could be 10. We don't know. So therefore, you might have said that this was not a mid-segment. However, here's why you would have been wrong. Because of these lines are parallel, then that makes these corresponding angles. So we know that these are going to be congruent. Similarly, these angles are corresponding angles. And since the lines are parallel, then these are equal. So that makes these triangles similar because they have all the same angles. So because these are similar triangles, and you already know that the small triangle is exactly half the big triangle. See how the small triangle has length 8 right here, but then the bigger triangle has length 16. So you know the bigger triangle is double the small triangle. So we might not know what these sides over here are, but we know, for example, if this is 7, we know that the whole triangle must be 14 because it's double the size. These are similar. So that means this would have to be 7. So they did give us enough information to know that this is the mid-segment. So you should have also circled this one. That was a little tricky. Number 5, we are told that these two triangles are similar. But which are the corresponding sides? Is the side BA corresponding with side AD? Or is side BA corresponding with side AE? How do we know? Well, here's how you know. Look at the sizes. 45 is the larger of the two sides that were given over here. So it's going to correspond to the larger of the two sides over here. So 36 is the biggest side, so these are corresponding. Okay, so of course these angles are congruent because of vertical angles, and then these sides are corresponding, and the 40 and the 32 are corresponding. So that's going to be enough to show us the similarity. So angle A of the left triangle is going to correspond to angle A of the right triangle. Okay. Now on the other hand, see how angle B is connected to the circle? Angle E is connected to the circle. That means those are corresponding angles. So angle E comes next. See how angle C is connected to the square? Angle D is also connected to the square. That's how you know that angle D comes last. Alright, for number 6, we are told that these triangles are similar. It would be useful to know the other angle, the measure of angle C. So we know that angles have to add up to 180 inside of a triangle. So if I start with 180 and I subtract 64, and 56. That tells me that the angle C is 60. Alright, now looking at the other triangle, I see a 56 and a 60, and here's a 56 and a 60. So that means that the other angle has to be 64. Alright, so angle A has a 64, angle Q has a 64, so those must be corresponding angles. Let's move on to angle B, which has a 56. Angle P has a 56, so that is next. And so now we've got Q and P, that just leaves R, which makes sense because R has a 60 and C has a 60, so those are corresponding. Now, find the measure of angle C and the measure of angle Q. Well, I'm pretty sure we just did that. So that's going to be 60 degrees and 64 degrees. Alright, problem number 7. Triangle JKL is similar to triangle RQP. The order of the letters tell us which sides are corresponding sides. For example, we have JK is first, so side JK must be proportional to side RQ. Well, these are corresponding sides. So JK is right here, and RQ is right here. So those are corresponding sides. Now, then we have KL and QP. So here's KL, and here's QP, even though there's nothing there. And finally, we have JL and RP. Okay, so JL, I think I'll put a heart on it, and RP. Okay, so now I've indicated all of the corresponding sides. So we need to find the value of x and the length of QR. So I'm going to consider this small triangle to be old, and I'll consider the bigger triangle to be new, although it doesn't really matter. But what I know is that new over old should equal new over old. Okay, because the sides are proportional when you have similar triangles. So let's see, new over old. That would be 40 over x plus 3. Okay, matching up those corresponding sides. That's new over old is 40 over x plus 3. Okay, new over old again. Can't do the circles because this one doesn't have any numbers. But I can do the hearts. So I will do 32 over 24. I like to reduce these, so I'm going to do 32 over 24. So that's 4 over 3. So I've got 40 over x plus 3 is equal to 4 over 3. So now we will cross multiply. Okay, I'm going to do this diagonal, and I'm going to do this diagonal. The yellow diagonal, so that's going to be 4 times x plus 3. The blue diagonal, that's going to be 120. So a little distributive property here, and I get 4x plus 12 is equal to 120. Subtract the 12 from both sides, and that's going to give me 4x equals 108. And then if I divide both sides by 4, that's going to give me x is equal to 27. Alright, so we were supposed to find that, so x is equal to 27. But then we're supposed to find QR as well. But we know that QR has the expression x plus 3. So if x is 27, then that's 27 plus 3, which is 30. Number 8 is a very similar problem. Find the side length marked x and the angle measure marked y. Okay, so again, the order of the letters tells us which sides are corresponding. So AB corresponds to ED. So here's AB and here's ED. Okay, and then BC corresponds to DF. So here's BC and here is DF. Alright, those are all corresponding. Okay, so I will consider this to be the old triangle and I will consider this to be the new triangle. It doesn't really matter which one you pick, but I will set up my equation by doing new over old is equal to new over old. Corresponding sides are proportional. So let's see, new over old, that will give me 20 over x, for example. Alright, looking at the circles. And new over old, 32 over 18. Alright, and then I'm going to cross multiply like you do. Alright, looking at the yellow diagonal, that's going to just be 32x. Let's see, 20 times 18, that's going to be 360. Then we'll divide both sides by 32. Alright, that is 11.25. Which, by the way, if you wanted to write that as a fraction, it would be 45 over 4. Okay, now we're supposed to find y. Well, y is the measure of angle D. And angle D corresponds with angle B. So I notice that the measure of angle B is 52 degrees. So that means that the measure of angle D is also 52 degrees. So that means that y is 52 degrees. Problem number 9, once again we're given similar triangles. We're told the order of the letters. So I know that, for example, AB corresponds with ED. So here's AB and here's ED. Those are corresponding sides. Okay, now let me skip over to AC. Alright, AC, that's the beginning and the end. So that's going to correspond with EC. Alright, AC and EC. So here's AC and here's EC. So those are corresponding. I'll consider this to be the old and this to be the new. And I'm going to do new over old is equal to new over old. Okay, so new over old, so that would be 6x plus 8 over 24. And then new over old, that would be 7x over 21. And then we cross multiply. So we will have our yellow diagonal and we will have our blue diagonal. You know, I could reduce these, but I don't want to confuse anyone, so I'll just keep doing what I'm doing. Okay, so I'm going to have 7 times 24. Alright, so that is 168x. Alright, and then I've got this 21 times 6x plus 8. So, got to do the distributive property, so I've got 168x is equal to alright, that's 126. And let's see, 21 times 8. That's 168. Okay. I have x on both sides, so I need to subtract 126x from both sides of the equation to get those terms together. Alright, so that's going to make 42x is equal to 168. So then I need to divide both sides by 42. And that's 4. So x is equal to 4. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.